I don't remember if I said that. We only looked at 2.1 through 2.3. So hopefully we can finish up this tonight. We'll see if we can. It depends on what we need to do and your questions. Okay, so if you remember some time ago when we started, we talked about compound interest, n times per year. And the other one that we have not talked about is continuously compounded interest. The formula that we looked at a long time ago was this: 1 plus r over n to nt. This one that I mentioned, but we did not do anything with it, was this. So if the interest is compounded n times per year, this is the accumulated value. Everything, all the information is the same. The accumulated value, the principal, the annual interest rate, and number of times we compound interest per year, and t's number of years. This is the formula we had before. Nothing new. This is kind of new because, as you see, there is no n in the formula. There is no compound interest n times per year because the formula gives us the continuous, every second the interest is compounded. And I like to look at a problem. Let me open my book. It's right here. I have everything ready. But then all of a sudden I was logged out, so I had to sign in again. So the whole thing collapsed on me. How can I be logged out when I'm with students in Zoom? I don't know. But it is what it is. Let's move on. Okay, so this is chapter 2. Okay, we're on page 203. I'm sharing my screen if it finally allows me to get there. Okay, so we want to look at 203. And here it is. An annual interest rate, time t is given. Find the value of the investment when interest is compounded annually, monthly, daily, continuously. Then find the doubling time for the given interest rate. So can anyone choose a problem, or I will choose a problem from 9 through 16?
We do 16.
Okay, so let's look at 16. So 16 has the principal as 12,000, annual interest rate 3.7%, and the time is in 9 months, but in the formula, time has to be in years. So we have to change that from months to years. Let's do that at the beginning. So here's the idea. We know that 12 months correspond to 1 year. 9 months will correspond to X. 12 months in a year, 9 months, how much? This is a proportion. 12 over 9 equals 1 over X. Proportion you can flip, but you have to flip both sides at the same time. So 9 over 12 equals X. We will simplify by 3, so we get X equals 3 over 4. So it's 3/4, which we knew. I just wanted to show you this side calculation. So it's 3/4 of a year. So you can change this into either 0.75 of a year or 3/4 of a year. And that is 9 months. Good. So now we go back to the problem for a moment. And it says annually, which means t equals 1 year. I'm sorry, n equals 1. That's what I meant. N equals 1 annually, once a year. Monthly, n equals 12. Daily, we consider 365. And then continuously. And then we'll talk about the doubling time. Okay, and continuously. So these are the options. If you remember what we did a long time ago, I don't want you to calculate this by hand several times. There is no need for something like this. You just put it in the graphing calculator as a function for those first three options. And here's how we do it. In y equals, you just enter exactly what we have. 12,000, parentheses, 1 plus 0.037. Remember, we cannot use percent divided by x, because x will be 1, 12, and 365. Close the parenthesis, caret, which is the power, and in parentheses we have 3/4 times x, or 0.75 times x, and close. So this is the formula in which x will be 1, and then it will be 12, and then it will be 365. If you do this 3 times separately, you may get errors. Once you see the function in there, it's always very easy to plug in 1, 12, and 365 in one blink. Okay, 1, 12, and 365. Okay, you have to go back and highlight to see what's going on, because the decimal digit, the portion of the beyond the decimal point, it does not show. So a of 1 equals 12,331.48. A of 12. Let's see what a of 12 is. Further down, 12,337.14. And a of 365, scroll down. Okay, so this is 12,337.65. Remember, in money terms, we have to round up to 2 decimal digits. Now, of course, the last one, you can create a function, but it's only one calculation. So there is no need for that one, unless you want to see and make sure that you enter it correctly, etc., etc. So this is 12,000. And remember, we are using e, so the second and natural log. And in parentheses, I have r, which is 0.037, multiplied by the number of years, which in this case is 0.75. Remember, all these numbers have to be extremely close to each other. So 12,331, 12,337, 12,337. This one has to be tiny bit more, but still 12,337. So be careful every time I assign a problem like this on a test. Students come up with 12,000, 20,000, 50,000, 60,000. It's not possible. Numbers have to be very close to each other. So for the, as you see, so for the continuous compound interest, so a continuous, if you want, that is 12,337.66. So now this part, find the doubling time for the given interest rate. What does this mean? It means that we start with a principal of 12,000, and we would like to determine the time required for the investment to double. So now the formula is 24,000 equals 12,000 e to r, which is 0.037 times t. So let's look again for one moment. Okay, initial investment of this, and annual interest of this, and the time they are given. Find the value, the future value of the investment when interest is come out. Then find E, the doubling time for the given interest rate. Okay. So they want us to denote, it doesn't matter, but this is uppercase T, it doesn't matter. You can change the notation as you please. Now, what type of equation is this? Can anyone remind us what it is? We solved a few last time. So what are they? What type of equation is this?
Logarithmic.
We don't see any log. Do you see a log or ln? No. So this is a constant, and the variable is at the exponent level. And there is no log and there is no ln. So therefore, this is a exponential. It is an exponential. Remember, the first step is what I'd like to say, which is not in mathematical terms, clean it up. Clean it up, please remember. How do I clean this equation up? Because at this point, I can't do much. What do you think we should do to clean it up? Assuming you don't know anything about exponential equations, what would you think of doing? Just look at it and say, oh, I know, I'm going to do this.
Can you multiply the E with 12,000?
You mean these two?
Yeah, since it's a constant.
By the order of operations, I have to address the power first. I could never multiply before I address the power, but you don't have the power. We have to solve for the power. So this is not
by
yes, by
20. You're dividing.
of course I have to clean it up. Absolutely. So 2 equals e to 0.037. Thank you, Haley. Of course, clean it up. Now, what did we do last time to solve such an equation? We had few examples and you had at least one on homework. What did we do now in the previous examples? What did you do on the homework to solve something like this?
Multiply everything to both sides.
Yes, we applied natural log to both sides, indeed. Because I need to bring the power down. Only applying natural log will do that. Only natural log has that property. It allows me to bring the power down. So we have natural log 2 equals 0.037t. Why don't I write times natural log e? Why don't I write times natural log e? Can anyone remind us why not?
Because it equals 1.
Because it equals 1. Very good. And the final step is t equals this over this. Natural log 2 over 0.037. And this is the time, if you want it uppercase T, as they want us to denote it, doesn't matter. The notation is not important. This will be the time in years required for this investment to double at this interest rate. One more time. We didn't calculate it. I have to put in the calculator. So whatever the number of years will be is the required number of years to turn this into its double at this interest rate. So let's see. What do we get? Natural log 2 divided by 0.037. 18.7 years, approximately. A lot at this interest rate. Good. Any questions on this problem? Is it understood? Yes, no.
Instead of using natural log on both sides, can you also convert it to the other form,
By other form, you mean?
the logarithmic? Or
You mean the common log, the log?
yes.
Absolutely, the result will be the same, but then you're going to have an extra quantity here, which is common log of e, which is not 1. So you make it a little more complicated. You should always use the log of the base, because the log of the base is always 1. But yes, you're going to get the same answer. It's nothing incorrect. Nothing incorrect. Okay, any questions other than this? Is this okay? Is it clear what I just said? GS, is this okay? You understand that you can apply natural log, but then you'll have here common log of e, which you cannot get rid of, so it will be here in the denominator, which is fine. You're going to get exactly 18.7 years guaranteed. Okay, I wanted to look at logarithmic equations now, because we did not get the chance to look at those, and then move on. So we established domain, and I would like to look at, again, if you want to choose something else, you're free to do so, please. But I'd like to also work on 61 through 68. These are log equations. Anyone would like to pick 61 through 68? If not, I will. Okay, I'll pick.
Can we do 63?
Yes, of course. 63, and we're going to look at 67 as well. Okay, 63. 2 natural log x equals 9. The first thought is clean it up. How are you going to clean this up? Any suggestions? How do we clean this up?
Divide the 2.
Divide both sides by 2. So I have natural log x equals 9/2. Perfect. Let me remind you, log base a of x is y. Log base a of x is y is equivalent to the base raised to y equals x. A raised to y equals x. This is the most important relationship between log equations and exponential equations. I don't know how to solve that. I have to change it into this. Can anyone tell us how to change natural log x equals 9/2? This is going back and forth. It's the double equivalency symbol. From here, here, and from here, here. This is what I have. I need to change it into this, into an exponential equation. How will I do that? Anyone would like to try? This is all.
Argument becomes an exponent and the base becomes argument.
So this is basically algebra. There is nothing here from calculus yet. So how do I change this into this?
I don't remember exactly, but isn't log natural basically the same log base e?
Exactly.
So it would be e to the
9. Exactly. E to 9/2 equals x. We like to write x equals e to 9/2. Not e to 9/2 equals x, but it's the same thing. Correct. The base raised to y equals x. The base raised to y equals x. And now we know what this is, and if we want, we can approximate it if there is a need for that. Again, this is nothing new. This is all algebra, but I wanted to show all of them, all types of problems. So with the graphing calculator, I will put E and the caret. Oh, no, I didn't mean that. So E parentheses 4.5. Good, so I got 90.02 approximately. Good, let's also, any questions? Let me stop sharing for a second. Any questions here? Anybody, any questions? Okay, so let's take a look at one more. So, is this okay, everybody? Please say something. Yes, no. Again, this is a review from algebra. Okay, so natural log of x plus 3 plus natural log of x minus 3 equals natural log 7. When solving logarithmic equations, we have two options. Option number 1, state domain. And option number 2, check back in the original problem. You don't have to be consistent. You can solve a problem with stating the domain and the next problem checking because you don't want to state the domain. It's up to you. I always prefer this because I may forget to go back and check. And this is mandatory. I have to go back and check. But if I state a domain, and the domain is, let's say, 0 to infinity, and I get that x equals -3, I don't have to check anything. I'll say no solutions because -3 is not here, and I'm done. But you can say, no, I don't want to state a domain, but I promise I will always check. It's fine. It's up to you. So, the domain for this, if you remember from last time, and the domain for this, how did we determine the domain of natural log of x plus 3? Anyone remembers? We had an example last time with domain. What did we write?
So it had to be